Hello, this is the second part of the video. So part 2 of section 2.2, and I want to focus on what's called the end behavior. It's called the leading coefficient. And this term, the highest term, dominates, and so I'm just going to make a note of that. The highest term dominates the function. And why? Because the bigger the exponent, the bigger the number. That's all it is. Simple as that. So for example, let's look at x equals minus 10. And first we're going to raise it to the first power. That's minus 10. Now we're going to raise it to the second power. 10 times as big. Negative times negative gives us to 1,000. So now we're going to look at x cubed. And that's minus 10 cubed. That's going to be 10 times 10 times 10, which is 1,000, but we have three negative numbers, an odd number of negative numbers. So we have 1,000, and then x to the fourth minus 10. We're going to have 4 zeros, so it's going to be 10,000. And since it's 4 minus signs, minus times minus times minus times minus, that ends up positive. So just notice that the bigger the exponent, the bigger the number. So when we want, our goal here is to graph these functions. Sorry, I don't mean to put it out of the way. And we want to graph them qualitatively. And what that qualitatively means is we just want the big picture, not the details. So we have, like before we were focusing on the details, here we're not. We just want the big picture of the graph. And if you have a specific function, you want to see what it looks like in more detail, you can use Desmos for detail. But I also want, if you understand qualitatively, then when you plug it in Desmos, you'll understand better what you see. So that's our goal. So again, I'm going to go back to these examples. I'm going to hold this so we can keep it up there. And since the highest term dominates, what I want to look at is the end behavior. And I'll show you what I mean by that. If we have a graph, what happened, this is the end behavior. What's going on over here for large negative numbers. And then what's going on over here for large positive. So if we can figure out what's going on over here and here, then we can sort of fill in some of the details later. So let's say the graph is really large in a positive direction for negative numbers, then our graph is going to go like this, and then it's going to come up like that. So that's what, if we want to know what's going on here, and then we can get the general shape of the curve. And then we'll use other things later on to sort of refine the shape. Does that make sense? Okay. Okay. So that's what we want to understand. So we're going to look at this function right here. I'm going to look at p of x equals 3x to the fourth. And I notice I'm not putting in the lower degree terms. And that's basically because for the end behavior, these don't matter. That's what matters. That determines what happens, because this is eventually, x to the fourth is eventually so much bigger than x to the cube, x third. Okay, so we want to know what happens for large x. So if x is large but negative, and let's use an example like 1,000, and then what happens if x is large but positive? So let's say, so that would be negative 1,000. That would be positive 1,000. So we just want to look at this function, realizing that these terms are not going to matter. So I'm just going to take a test value. That's a test. I want to see what happens when I raise it to the fourth power and multiply it times 3. It's going to be 3 times 1,000 to the fourth. That's actually going to have 12 zeros there, so we're getting up into the quadrillions or something like that. Okay, so it's going to be huge. It's going to be a very big. We plug in x equal minus 1,000, multiply it by 3, raise it to the 4th power. We're going to get a very big positive number. And so that tells me that the graph is going to start high on the left. Okay. So, and then if I look at a positive number, let's say 1,000, I'm going to test it for 3x to the 4th. That's going to be 3 times 1,000 to the 4th, and that's going to also be a very big positive. So that means the graph is going to end here. So it's going to start here and end here. Now we don't know what goes on in between. So I'm just going to make a guess. So the graph is going to look something like this. That's my guess. And then come back up. So that's my guess. So if I knew all the numbers and I plugged this into Desmos, I would expect some variant like that. Okay. So notice that a large positive exponent means you're going to start over here. I'll summarize this behavior later. Okay. So let's look at this number right here, p of x, the second equation, 2x cubed, and again we're leaving the other coefficients unspecified because again the highest power dominates. That power right there. So again, I want to do the same thing. I want to find out where the graph starts. I'm going to test with a large negative number. And I get 2 minus 1,000 cubed. Again, I get a big number. It's not as big as I got the number before, but it's going to be a negative because I get 3 negatives. Negative times negative times negative is negative. So it's going to be a large negative number. So that tells me that the graph is going to start here. And I want to see where the graph ends. I'm going to test with a large positive number. I look at 2 times 1,000 cubed, and that's going to be a large positive number. So that means the graph is going to end up here. Okay. Now again, I don't know what's going to happen between here and here, but I'm just going to make a guess. It's going to be something like this. Okay. So that's going to be my guess at the graph, this piece right here. Okay. So I want to do, again, I'm going to show you what happens. So I want to show you what happens with f of x. Let's do the same two examples we did before, but we're going to make the leading terms negative. So we can have 3x to the 4th, and again, unspecified terms. Because again, we're just saying that the highest power dominates for the end behavior. That's all we need to look at. So for the end on the left, I'm going to plug in x equals, again, minus 1,000, but it's going to be minus 3 this time. Again, I'm going to have 5 negatives. That's going to leave me with the negatives. I'm going to have a negative large number. So if I plug in a value, it's over here to the left, the graph is going to start down here. Okay, then I'm going to do I should say that's the beginning, because we go from left to right. And then if I want to see the end, what happens on the right, I do the same thing. I'm going to plug in x equal 1,000. Again, a big positive number. I'm going to look at minus 3 to the 4th power. Minus 3 times that's going to give me a large negative, so I'm going to get a large negative number. So I'm going to end here. So what's going to happen, we saw that when everything was positive, that the graph went like this. It went like a W. So here's what it looked like when everything was positive. When it's negative, it's just going to be the opposite. It's going to start down here, go up, turn around, go up maybe some more and turn around. It's going to look like that. And finally, we want to look at what happens for my other example, when that 2 was negative, before, what happened was when the 2 was positive, it looks like this. So the 2 is negative, it's going to flip everything around. So we'll see what happens. So we want to see what happens where it starts, and that's on the left. I'm going to plug in a test value. X equals, again, minus 1,000. I'm going to have minus 2 minus 1,000 cubed. I'm going to have 3 negatives here, 4 negatives here, so I'm going to have a large positive number. So I'm going to start up here. And then I'm going to end on the right. I'm going to test a large positive number, a number from way over here, so x equals 1,000. So I get minus 2, 1,000 cubed. I just have the one negative sign. That's going to be a large negative number. So I'm going to end right here. So again, my graph is going to start here. Maybe it turns around and comes back down here. And again, notice that's what happens when we have a minus 2. This is what happens with the plus 2. So I want to summarize this behavior. That'll be the end of the video. We'll talk about adding more detail in the next video. So I want to share the screen, and there's just a PowerPoint that I think is helpful. So you have these slides. I uploaded them, but I think this is just I think I'd like to show this and comment. When n is even and a is greater than 0, so we're looking at this. Sorry, an is greater than 0. What happens is we're going to start high and then end up going low. Okay. And then coming back up high again. Okay. Now, if the leading coefficient is negative, then it's going to be the opposite. So I want to show you that picture, and then I'm going to just kind of reiterate that over here on the graph. So I'm going to stop the share and go back so you can see the paper. So this is what it looks like. What happens here, if n is even, an is greater than 0, it starts upper left, and it ends the upper left. So it looks something like this. Starts here, it ends over here, and the graph's just going to go down and come up again. Okay. Now, if we have the same idea, so I'm not going to bother to write all the other terms here. But here where an, leading coefficient, is negative, it's the opposite. It starts and ends low. So we would have, instead of this, the graph would look something like this. And again, that is because when n is even, this is going to be a large positive number, no matter what sign x is. Because we got positive times positive. When n is even and an is negative, we're going to have a negative times a large number. And that's why we see this behavior. Okay. So let me show you the next one. But first, I want to advance the slide. Okay. Now I'm going to share that. Sorry, the share is taking a little bit of time. So here we have the opposite, where n is odd. When an is positive, we see that we start low, and then we end up high. And if an is negative, we're going to start high and end up low. And again, I am going to summarize these, go through these on paper so we can see it. And I'll take this off the screen in a second. So we have n odd and an greater than 0. Okay, so I'm going to stop the share. So what happens when n is odd is we get large. If x is equal to a large negative, then P of x is large negative. If x is equal to a large positive, P of x is going to be a large positive. And so what happens is the graph here, it will look like something like this. It'll start low and end high. So the graph could look like this, could go up and down and then come back up. Okay. And then if P of x is the same thing, this time we have n odd, but an is negative. Then if we plug in, if x is a large negative number, we're going to have P of x equals a large 1 negative, and then we have an odd number of negatives here. It gives us an even number of negatives. So we're going to have a large positive. And if x is equal to a large positive number, P of x, well, x to the n will be positive, but the an is going to make it negative. So we'll have a large negative number. So our graph will look like this. It'll start high and end low. So go like this. Start here, go up and down a few times, and then end low. So the opposite of that. Okay, so that's called the leading coefficient test. And like, oops, sorry to do that. And like I said, that's summarized on the slides. Just to show you again, we're summarizing the negative case. And as you see, this is what the negative case looks like. It start when n is odd and the leading coefficient is positive, it starts low and goes high. When the leading coefficient is negative, it starts low, turns around, does its thing, and then it ends up low. Okay, so that's it. So thank you, and I'll do some examples in the next video.